Hey guys, Marvelous Max is back, and today I'm going to start off with a seemingly simple question. What's similar about all these pictures? So you have a pinecone, you have a galaxy, you have a seashell, and you have a fingerprint. Well, you can pause this video and work it out, but anyways, today we're going to be learning about the Fibonacci sequence. Well, the Italian mathematician Leonardo of Pisa, also known as Fibonacci, introduced Western Europe into the Fibonacci sequence, although Indian mathematicians already knew about it. Well, the sequence goes 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. Well, if you don't see the pattern here, well, the last number and the present number is the next number. So you have 1 add 1 is 2. 2 add 1 is 3. 3 add 2 is 5. 5 add 3 is 8. 8 add 5 is 13. 13 add 8 is 21. 21 add 13 is 34, and so on. Well, if you took a stroll outside and count the petals of a flower, it would actually probably be a Fibonacci number. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. And as you can see with all these flowers, they have the petals of a Fibonacci number. So what if you square the Fibonacci number, huh? Well, you would get 1, 1, 4, 9, 25, 64, 400, and 441, and so on. Well, if you add the square numbers, then you get one, so you have 1 and 1 is 2, which is 2 times 1. And you have 1 at 4, which is 6, which is 3 times 2. And then you have 1 at 4 and 9, which is 15, which is 3 times 5, and so on. So you get 40, which is 8 times 5, 104, which is 8 times 13, and 273, which is 13 times 21. The next thing you need to know about Fibonacci is the Fibonacci spiral. So you had a 1 by 1 square, next to it put another 1 by 1 square. Underneath it put a 2 by 2 square, and next to that put a 3 by 3 square. On top of that you put a 5 by 5 square, and next to that you put an 8 by 8 square. And then join all the corners and you would get a spiral. Now back to the question I asked at the start of the video. What's similar about all these? Well, they all relate to the Fibonacci spiral. So this galaxy is spiral. This seashell is obviously spiral, and this fingerprint is actually spiral. I'll talk about the pinecone later. In fact, I'll tell you about it right now. So I have this pinecone here, and then the rows go in spirals. So you have 1 row of spirals, 2 rows of spirals, 3 rows, 4 rows, 5 rows, 6 rows, 7 rows, 8 rows, 9 rows, 10 rows, 11 rows, 12 rows, and 13 rows. And 13 is a Fibonacci number. So, and if I do the spirals the opposite way, then you get 1, 2, 3, 4, 5, 6, 7, 8, and you get 8 sets of spirals, which is also a Fibonacci number. Let me bring up another pine cone and then draw an outline of it and remove the picture so you can actually see better than when you do this. So now I'm going to color code the spiral so you can see better. So you have 1 set of spirals, 2 sets, 3 sets, 4 sets, and 5 sets. That's a Fibonacci number. And if I do it the opposite way, you get 1, 2, 3, 4, 5, 6, 7, 8 sets, which is also a Fibonacci number. The next thing I want to talk about is an experiment I like to call finger Fibonacci. So look at your hand. You have 2 hands, which is a Fibonacci number. Each have 5 fingers, which is also a Fibonacci number. Each of which has 3 parts separated by, which is also a Fibonacci number. 2 knuckles, which is as well a Fibonacci number. You can see all of these are Fibonacci numbers, and I've color-coded them in blue. But just remember one thing. Fibonacci isn't always in nature. So you have 3 sided peppers, but you can also get four-sided peppers. Here you have a four-petal flower, and here you have a six-petal flower. And the next thing we're going to talk about, which I said we'll talk about in the video, is the golden ratio. What it is basically, say I had 2 and 1, if I divide them, I get 2, and I had 3 and 2, I would get a 1.5, and I have 5 and 3, I divide them, and I get 1.666, and so on. And you would realize the more I divide these numbers, the closer I get to phi, also known as the golden ratio, which is equal to 1.618. And I thought you needed to know that just for sure. So the next thing we're going to learn about is phi in art and architecture. So first here you have the Eiffel Tower, which fits in the golden rectangle. What the golden rectangle is, it's basically just a rectangle, but when you divide the length by the width, you get phi. So that's the golden rectangle. And that's the same thing with the Parthenon in Greece. It fits in the golden rectangle. And then you have the Mona Lisa, which fits in the Fibonacci spiral. Actually, surprisingly, that's why it looks so good. And then you have the Pyramid of Giza. So when you divide the slant height by half of the base height, by half of the width, you get phi. So that's pretty much it for today. But if you enjoyed this video, then go outside and try looking for phi, because it's really everywhere.